Our objective today is I can name and write formulas of acids and bases. So first let's distinguish between acids and bases. Acids taste sour. They are electrolytes, which means they can conduct an electrical current. And if you have an indicator, it would change color in the presence of an acid. Litmus paper is one example, which turns red when dipped in the presence of an acid. Some examples of acids in your household would be citric fruits and vinegar. Bases taste bitter. They feel slippery, and they are also electrolytes. Indicators change color in the presence of a base. Litmus paper specifically turns blue when you dip it in a base. Some examples of bases in your house would be soap or ammonia. Now we're going to focus on how to name acids and bases. The very first thing you've got to know is that all acids start with hydrogen. So any acid is going to have hydrogen in the front of its formula. All acids start with hydrogen. So you see HCl, HBr, H2SO4, H3PO4, all of them start with hydrogen. These are all acids. The second thing you need to know is that there are two different kinds of acids. There's binary acids, which have no oxygen, and then there are oxyacids, which do have oxygen, which are from polyatomic ions. So a binary acid is just hydrogen plus one other element, whereas an oxyacid is hydrogen plus a polyatomic ion that ends in either ate or ends in ite. So now let's kind of focus on the short version, and then I'll show you kind of the long version. So here's the short version. If you have a binary acid, there's no oxygen, the name is going to start with hydro and end in ic acid. The anion is going to end in ide, IDE. If you have an oxyacid, your anion ends in ate or ite, and it does have oxygen. Ates, you're going to drop the ate and it's going to become an ic acid. You're going to drop the ite, it becomes an us acid. And you can think, I ate something icky, it tried to bite us. To try and remember, ate becomes ic, ite becomes us. So now let's kind of walk this through one step at a time. All acids start with hydrogen, so what I want to focus on is not the hydrogen but the anion. This is chloride. Because it ends in ide, that means that the acid name is going to be a prefix of hydro, and then this is the root. Chlor is the root. So that'll go here. And then I'm going to end it with a suffix of ic acid. So that's going to be hydrochloric acid. Here, the Br, there's no oxygen, so this is bromide. And because it ends in IDE, I'm going to have a prefix of hydro. My root is brome, so it'll be brome, and then I'm going to put ic acid at the end. Okay, so that would be if you have a binary acid. No oxygen, they end in ide, and they become a hydro something ic acid. If we do have oxygens, then we have two scenarios. We have the scenario where if your anion ends in ate, it becomes an ic acid. If it ends in ite, it becomes an us acid. So let's look here. H2SO4. Every acid starts with hydrogen, so I want to focus on the SO4. That is a polyatomic ion, so I want to refer to my list of polyatomic ions on my star reference chart. So I want to look for SO4, and you'll see it right here. SO4 has a -2 charge, and the name of that is sulfate. So this is sulfate. And since it's sulfate, we're going to not start the name with hydro. We're just going to put the root and end it with ic acid. Sulfur is a little bit special. We're not going to put sulfic acid. We're going to stretch it out a little bit and call it sulfuric acid. That is the exception for sulfur and phosphorus. So here's the phosphorus exception. PO4 is a polyatomic ion. So I'm going to go look at my list of polyatomic ions and find PO4 is here. PO4, -3, is phosphate. So this is phosphate. Since it ends in ate, I'm not going to start the name with hydro, and I'm going to exchange 8 for ic acid. But it's not going to be phosphoric acid. It's going to be a little bit more stretched out, phosphoric acid. These are the only 2 exceptions where you have to do that. Everything else, you can just drop the 8 and put ic acid. Okay, if you have an ite, like down here, so we're going to look at SO3, and in our list of polyatomic ions, SO3 is sulfite. So this is sulfite. Since it ends in ite, I will not start the name with hydro. It's just going to be sulfurous, ite changes to us, sulfurous acid. Down here, NO2, if I go find NO2, I find that NO2 is nitrite. So this is nitrite. And since it ends in ite, I will not start with hydro. It's going to be and I'm going to replace ite with us acid. It's going to be nitrous acid. So one more time with our little shortcut. See here with my short version of it, it's if you have a binary acid, there's no oxygens, the suffix of "ide," we're going to change it to be a hydroic acid, right? If I have an oxyacid, it does have oxygens. 8 becomes ic acid, and then ite becomes us acid, right? And so those are our 3 different ways to change the anion to the name of the acid. Okay, if I'm naming bases, all bases end with hydroxide, or OH. So all acids start with hydrogen, all bases end with hydroxide. So to name a base is pretty simple. You just have to name the metal followed by hydroxide. So this is magnesium hydroxide. And this one is aluminum hydroxide. So pretty straightforward. I do want you to notice the reason why there's a little 2 subscript here is because the magnesium on the periodic table is a +2 charge. Hydroxide has a -1 charge. So we have to balance charges. So this, because that's a +2, that means we need 2 hydroxides. A -1 needs, I just need 1 magnesium. So here, aluminum is a +3, hydroxide is a -1. So if we crisscross, we need 1 aluminum, 3 hydroxides. So the reason the formula is the way it is to balance the charges. So now we need to do the reverse, write the formula for the acids and the bases in reverse. So for our reverse engineering, I want to look here at the nitric acid. And was it nitride, nitrate, or nitrite? Notice it does not start with hydro, so it's not nitride. And because it ends in ic acid, it must have been nitrate. So I'm going to write here that it was nitrate. And now that I know which ion it was, I can go look for it on my list. And here is nitrate, NO3, with a -1 charge. The charge is very important. NO3, -1 charge. So now that I know what my anion is, I can write my formula. All acids start with hydrogen. And remember, hydrogen is a +1. So +1, -1 are going to cancel, or you can just look at the charge of the anion, and that tells you the subscript you need for your hydrogen. So I only need 1 hydrogen, and then I'm going to write the rest of my anion's formula, NO3. Now let's look here. Reverse engineer sulfurous acid. Well, it does not start with hydro, so it's not sulfide. Is it sulfate or sulfite? Well, it ends in us acid, so it was sulfite originally. So we'll write sulfite here. We'll go look at our list of polyatomic ions, and we'll see that sulfite is SO3, -2 charge. SO3, -2. So to write the formula, all acids start with hydrogen. Since this is a -2 charge, I'm going to need a subscript of 2 on the hydrogen, because +1 -2 switch. And then I'll put my SO3 for the rest of my anions formula. Okay, next is hydrophosphoric acid. And so is it phosphide, phosphate, or phosphite? Well, since it starts with hydro, then it must be phosphide. So phosphide is not on the list of polyatomic ions. You're going to have to go look it up on the periodic table. I look on the periodic table. This is my "ide" section where I have -3, -2, and -1, my charges. And so phosphide is P with a -3 charge. And so it's P with a -3 charge. And so all acids start with hydrogen. Since the charge is -3, I need a subscript of 3 next to hydrogen, and then I'll put the anion P right there. The last example, lithium hydroxide. When you see the name hydroxide, that means it's a base. So I just need to write the formula. Lithium, I have to go look at the periodic table. Here's lithium. It has a charge of +1. I don't care about the number of valence. I want the charge. Lithium is a +1 charge. So this is Li +1. Hydroxide is OH -1. Since +1 and -1 cancel, that gives me a formula of just LiOH. Now you can pause the video and practice writing the acid and base names and acid and base formulas for these. Unpause the video and then watch the answers. So because this is sulfide, its name is hydrosulfuric acid. And the formula is going to be H, that -2 puts a 2 here, and then I'll put the S. Phosphate, it ends in 8, so it's going to be phosphoric acid. And then I'm going to put a big H in front because there's a -3 charge. I need a subscript of 3, and then I'll write the PO4 as the rest of it. Beryllium, if I want it to be a base, I'm just going to add hydroxide next to it. Beryllium hydroxide. And then you see that +2 charge? That tells you that you're going to have Be, OH, and 2 of them. Be sure to have parentheses around your hydroxide. Cesium hydroxide is this base name. There's a +1 charge on cesium, so that is going to cancel with the ±1 on hydroxide, so it's just CS and then OH for hydroxide. Here are some famous acids. Burning fossil fuels will cause acid rain, which is sulfuric acid and nitric acid mixed together. The acid in your stomach is hydrochloric acid to help you digest your food. Sodas contain phosphoric acid. Car batteries contain sulfuric acid. And if we look at a pH scale, this allows us to compare the strengths of acids and bases. The pH value measures the amount of hydrogen ions that are present. The more hydrogen ions, the more acidic your substance is. So, according to the scale, if you have a pH equal to 7, you have a neutral substance. If you have a pH that is less than 7, it is acidic. And if you have a pH greater than 7, it is basic. And of course, the full range of the pH scale is from 0 up to 14. Each number is different than the one before by a factor of 10. Remember that numbers closer to 0 are stronger acids, while numbers closer to 14 are stronger bases.